Configure VTP and DTP. Addressing table, 6 PCs and 3 switches. Okay, 3 switches and PCs. As the numbers of switches in the network increases, the administration necessary to manage the VLANs and trunks can be challenging. To ease some of the VLAN and trunking configurations, VLAN Trunking Protocol (VTP) allows a network administration to automate the management of VLANs. Trunk negotiation between network devices is managed by the Dynamic Trunking Protocol (DTP) and is automatically enabled on Catalyst 2960 and Catalyst 3560 switches. You will configure trunk links between these switches. You will configure a VTP server and VTP clients in the same VTP domain. You will also observe the VTP behavior when a switch is in VTP transparent mode. You will assign ports to VLANs and verify end-to-end connectivity with the same VLAN. Configure and verify DTP. You will configure trunk links among the switches, and you will configure VLAN 999 as the native VLAN. Verify VLAN configuration. Verify the configured VLANs on the switches. On S1, click the CLA tab. At the prompt, enter enable and enter show VLAN brief command to verify the configured VLANs on S1. Repeat step A on S2 and S3. Okay, go to S1, click here, then CLA, enter, enable, show VLAN brief. Okay, VLAN 1, the default VLAN, VLAN 99 management, and VLAN 999 with the default name. Okay, S2, CLA, enter, enable, show VLAN brief. Okay, 199 and 999, S3, CLA, enter, enable, show VLAN brief. 199, 999. What VLANs are configured on the switches? Okay, VLAN 1 is the default. It's not configured. And the answer is VLAN 99 and VLAN 999. Configure trunks on S1, S2, and S3. Dynamic Trunking Protocol (DTP) manages the trunk links between Cisco switches. Currently, all the switch ports are in the default trunking mode, which is Dynamic Auto. In this step, you will change the trunking mode to Dynamic Desirable for the link between switches S1 and S2. Okay, this link between S1 and S2. For the link between switches S1 and S3, the link will be set static trunk. Use the VLAN 999 as the native VLAN in this topology. Okay. On switch S1 and S2, configure the trunk link to Dynamic Desirable. On the gigabit interface, gigabit 01, the configuration on S1 is shown below. Okay, this is the example. Okay, on gigabit 01 on S1, configure terminal interface gigabit 01, switch port mode, dynamic desirable. Okay, sorry, desirable. Enter. Very good. Okay, on gigabit 01, switch port mode, dynamic desirable. And also on S2 gigabit 01. Okay, gigabit 01 on S2. In a configure terminal interface gigabit 01, switch port mode dynamic desirable. Enter. Very good. For the trunk link between S1 and S3, configure a static trunk link on the gigabit 02 interface. Okay, on S1 gigabit 02 switch port mode trunk, and on S3 gigabit 02 switch port mode trunk. This link go to S1 interface gigabit 02 and switch port mode trunk. Enter. Very good. And go to S3, configure terminal interface gigabit 02, switch port mode trunk. This is static trunk configuration. Verify show interfaces trunk. Go to S1 and show interfaces trunk. Now you can see gigabit 01, the mode is desirable, AO2.1q. Okay, N for negotiated. This N for negotiated. But the status is trunking, native VLAN is 1. Okay, in gigabit 02 is on because it's static. Encapsulation AO2.1q, status trunking, native VLAN also 1. What is the native VLAN for these trunks? Currently, the answer is VLAN 1. Okay, VLAN 1. Configure VLAN 999 as the native VLAN for the trunk links on S1. So choose the range gigabit 01 and 2 and switch port trunk native VLAN 9 and use this command. Go to S1, configure terminal interface range gigabit 01 and 2, switch port trunk native VLAN 999. Very good. And look at this message. Receive it BPDU with inconsistent peer VLAN ID, blocking gigabit 01 on VLAN 999, inconsistent local VLAN. What message did you receive on S1? This message. Okay, all this message. How would you correct it? This is the message native VLAN mismatch. Okay, to correct native VLAN mismatch, you need to configure the same native VLAN on S2 and on S3. Okay, on S2 and S3, configure VLAN 999 as the native VLAN. Go to S2, enter gigabit 01, switch port trunk native VLAN 999. On S3, enter gigabit 02, gigabit 02, switch port trunk native VLAN 999. Okay, unblocking port gigabit 02, port consistency restored. Go to S2, go to S1, port consistency restored. Verified trunking is successfully configured on all the switches. You should be able to ping one switch from another switch in the topology using the IP addresses configured on the switch VLAN interface. Okay, go to S1 and verify, enter, and show interfaces trunk. Native VLAN is 999, but go to S2 and show interfaces trunk. Okay, 999, mode desirable, negotiated, AO2.1q trunking, S3, and show interfaces trunk. Mode on, static, Very good. On S1, the IP address of S2 on VLAN 99 is 192.168.99.2, and on S3 is 3. Okay, go to S1, enter ping 192.168.99.1. Okay, this is the ping to myself, ping to S2. From S1 ping to S2 success. Repeat. Okay, ping to S3. Success. Ping again. All success. Configure and verify VTP. S1 will be configured as the VTP server and S2 will be configured as a VTP client. All the switches will be configured to be in the VTP domain CCNA and use the VTP password Cisco. VLANs can be created on the VTP server and distributed to other switches in the VTP domain. You will create 3 new VLANs on the VTP server S1. These VLANs will be distributed to S2 using VTP. Observe how the transparent VTP mode behaves. Configure S1 as a VTP server. Okay, click on S1, enter, enable, configure, terminal, and configure S1 as a VTP server, VTP mode server, VTP mode server, and CCNA as the VTP domain, CCNA case sensitive, Cisco as the VTP password Cisco. Verify VTP on S1, show VTP status. Okay, and show VTP status. Because the VTP version is 2. Number of existing VLANs 7. VTP domain CCNA, VTP mode server. To verify the VTP password, show VTP password. Show VTP password. Okay. Cisco. Add S2 and S3 to the VTP domain. Before S2 and S3 will accept the VTP advertisements from S1, they must belong to the same VTP domain. Configure S2 as a VTP client with CCNA as the VTP domain name and Cisco as the VTP password. Remember that VTP domain names are case sensitive. Configure S2 as a VTP client in the CCNA VTP domain with the VTP password Cisco. Okay, go to S2, enter, enable, configure terminal. Okay, VTP mode client and VTP domain CCNA and VTP password Cisco. VTP mode client, VTP domain CCNA case sensitive. Okay, VTP domain CCNA and VTP password Cisco. Okay, verify and verify the password, show VTP password. Okay, Cisco. Configure S3 to be in CCNA VTP domain with the VTP password Cisco. Switch S3 will be set to VTP transparent mode. Okay, VTP mode transparent, CCNA the domain, and password Cisco. Go to S3, enter, enable, configure terminal. VTP mode transparent, VTP domain CCNA, and VTP password is Cisco. Enter. Show VTP status on all the switches to answer the following questions. Okay, on S1, show VTP status. On S2, show VTP status. On S3, and show VTP status. Notice that the configuration revision number is 0 on all 3 switches. Explain. Okay, go to S1, configuration revision 0, S2, configuration revision 0, S3, configuration revision 0. Okay, the configuration revision number increments by 1 every time a VLAN is added, deleted, or modified. No additional configurations have been made on the VLANs on the switches. Create more VLANs on S1. Create VLAN 10 and name it red. Okay, go to S1, configure terminal VLAN 10, name red. Case sensitive. Create VLANs 20 and 30 according to the table below. 20 blue, 30 yellow. Okay. 20 name blue, 30 name yellow. Verify the addition of the new VLANs. Show VLAN brief. Okay, and show VLAN brief. Show VLAN brief. 10, 20, 30, 99, 999. Which VLANs are configured on S1? Okay, these VLANs 10, 20, 30, 99, 999. Confirm configuration changes using the show VTP status command on S1 and S2 to confirm the VTP mode and domain are configured correctly. Okay, on S1, show VTP status. VTP version 2, configuration revision 6. Okay, you created 3 VLANs and set the name of the VLANs. 1, 2, 3, 4, 5, 6. 6 configurations on the VLANs, including the names. So that's why the configuration revision is 6. Okay. VLAN 10, create the VLAN and name, modify the VLAN. Go to S2, show VTP status, VTP version 2, configuration revision 6, VTP mode client. How many VLANs are configured on S2? Number of existing VLANs 10 on S2. You can verify also show VLAN brief. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 VLANs. Okay, 10 VLANs. Those S2 have the same VLANs as S1. Okay, go to S1. Number of existing VLANs 10. So the answer is S2 has 10 VLANs, the same number as S2, because S1 is the VTP server and S2 is the VTP client. S2 has received the VLAN information from S1. Observe VTP transparent mode. S3 is currently configured as VTP transparent mode. Show VTP status. Go to S3. Show VTP status. Enter. How many VLANs are configured on S3 currently? Okay, 7. Show VLAN brief to verify again. 1, 2, 3, 4, 5, 6, 7. What is the configuration revision number? Then explain your answer. The configuration revision number is 0. Okay, the configuration, so the answer is the configuration revision is 0 because S3 is in transparent mode and VLAN configurations have not been changed. How would you change the number of VLANs on S3? Okay, S3 is configured in transparent mode, and S3 will not receive information from the VTP server. Okay. To change the number of VLANs on S3, you need to configure the VLANs manually on S3 or configure S3 as VTP client. Change VTP mode to client on S3. Okay, on S3, configure terminal VTP mode client. Enter. Show commands to verify the changes on VTP mode. How many VLANs exist on S3 now? Okay, and show VLAN brief. And you will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 VLANs. Show VTP status. 10 existing VLANs. Configuration revision 6. Okay. Assign VLANs to ports. Use the switch port mode access command to set access mode for the access links. Use the switch port access VLAN to assign a VLAN to an access port. Okay, and configure this table. Okay, S2 from 1 to 8, go to S2. Configure terminal interface range Ethernet 1 to 8. Okay, to VLAN 10. Okay, switch port mode access, switch port access VLAN 10. 9 to 16 VLAN 20. 9 to 16 VLAN 20. 17 to 24 VLAN 30. 17 to 24 VLAN 30. And go to S3. Configure terminal interface range Ethernet 1 to 8. Okay, 1 to 8 VLAN 10. Switch port mode access. Switch port access VLAN 10. 9 to 16 VLAN 20. 9 to 16 VLAN 20. 17 to 24 VLAN 30. 17 to 24 VLAN 30. Verify end-to-end connectivity. From PC0 ping PC5. Go to PC0, desktop, command prompt, ping PC5. PC5 IP address is 192.168.10.2. Success. PC1 to PC4. PC1 ping to PC4. 192.168.22. 192.168.22. Success. And finally, PC2 to PC3. PC2. Desktop command prompt. Ping to PC3. 192.168.32. Ping 192.168.32. Success. Completion 100%. Thank you very much.